Dear students, now let us study about laws of indices and surds. Simplification using laws of indices. Let us consider an algebraic term 3x to the power n, where n is a positive integer. Here, 3 is the coefficient, x is the base. X to the power n indicates the product of n factors, each equal to x. And n is called the index, or the exponent, or the power of x. Students, any algebraic term has three parts. They are coefficient, base, and index. We apply the following laws of indices to simplify expressions involving indices. A to the power m into a to the power n is equal to a to the power m plus n. A to the power m divided by a to the power n is equal to a to the power m minus n. A to the power m whole to the power n equals to a to the power m into n. N under root a equals to a to the power 1 by n. A to the power 0 is equal to 1, and a to the power minus n is equal to 1 divided by a to the power n. Laws of indices. First, product law of indices. Students, we have a square into a cube. Here, a square can be written as a into a, and a cube can be written as a into a into a. So the expression becomes a into a into a into a into a. That's equal to a to the power 5, which can be written as a to the power 2 plus 3. Similarly, a square into a to the power 4 can be written as a into a into a into a into a into a. That is equal to a to the power 6, or a to the power 2 plus 4. So, to find the product of a to the power m and a to the power n, where a to the power m is equal to a into a into a into so on to m factors, and a to the power n equals to a into a into a into a and so on to n factors. Therefore, a to the power m into a to the power n is equal to a into a into a to up to m factors into a into a into a to n factors. That is equal to a into a into a to m plus n factors. This can be written as a to the power m plus n. Hence, a to the power m into a to the power n is equal to a to the power m plus n. Similarly, a to the power m into a to the power n into a to the power p is equal to a to the power m plus n plus p, and a to the power m into a to the power n into a to the power p into a to the power q is equal to a to the power m plus n plus p plus q, and so on. Thus, the product law of indices can be stated as the index of the product of the two or more algebraic terms with the same base is the sum of the indices of each term. Quotient law of indices. Students, we have a to the power 6 divided by a to the power 2. This is equal to a into a into a into a into a into a divided by a into a. After simplification, we get a into a into a into a. That is equal to a to the power 4, which can be written as a to the power 6 minus 2. Similarly, when we are given a to the power m divided by a to the power n, we write it as a into a to up to m factors divided by a into a to up to n factors. This can be written as a into a to up to m minus n factors. That is a to the power m minus n, where a is not equal to 0. Thus, the index of the quotient of the two algebraic terms with the same base is the difference of the indices of each term. Power law of indices. Students, we have a to the power m whole to the power n. We can write this expression as a to the power m into a to the power m into a to the power m to up to n factors. This is equal to a to the power m plus m plus m to up to n factors. This is equal to a to the power mn. Thus, the power of an index of any algebraic term is the product of two powers. It also holds true for a to the power m whole to the power n whole to the power x whole to the power y, which is equal to a to the power m n x y. Now, root law of indices. Students, we have a to the power p by q whole to the power q. Now, by applying power law of indices, we can write it as a to the power p by q into q. Hence, we have a to the power p by q whole to the power q equals to a to the power p by q into q, or a to the power p by q whole to the power q equals to a to the power p. Taking the qth root of both sides, we get a to the power p by q equals to q under root a to the power p. Thus, a to the power p by q is equal to the qth root of a to the power p. Thus, a to the power 1 by 2 is equal to under root a to the power 1 by 3 is equal to 3 under root a, 7 to the power 3 by 2 is equal to under root 7 to the power 3, 7 to the power 4 by 3 is equal to 3 under root 7 to the power 4, and so on. Law of zero index. Students, we know from quotient law of indices that a to the power m divided by a to the power n is equal to a to the power m minus n if a is not equal to 0. Therefore, a to the power m divided by a to the power m equals to a to the power m minus m, which is equal to a to the power 0. Now let this be equation 1. But a to the power m divided by a to the power m is equal to a to the power m divided by a to the power m equals to 1. Let this be equation 2. Thus, from equation 1 and 2, applying axioms of equality, we have a to the power 0 equals to 1. Thus, 8 to the power 0 equals to 1. 100 to the power 0 equals to 1. 3 by 4 whole to the power 0 equals to 1, and so on. Thus, any algebraic term having the index 0 is always equal to 1. But 0 to the power 0 is not equal to 1. Law of negative index. Students, here we have been given a to the power m into a to the power minus m. Applying product law of indices, we can write it as a to the power m minus m, which equals to a to the power 0, which is equal to 1. Now we get a to the power m into a to the power minus m equals to 1. Dividing both sides by a to the power m, we get a to the power m into a to the power minus m divided by a to the power m. This equals to 1 by a to the power m. On simplification, we get a to the power minus m equals to 1 by a to the power m. Thus, 3 to the power minus 2 is equal to 1 by 3 to the power 2. 3 to the power minus 3 by 4 to the power minus 2 equals to 4 to the power 2 by 3 to the power 3, and so on. Thus, algebraic term with negative index is the reciprocal of the term with the positive index.